Hi everyone, this is John McKeever from Data Migrators. Today I want to show you a practical demonstration of how you can get DataStage jobs running natively in your Google Compute Platform environment, and specifically your Google Kubernetes engine. But before I go on and do that, I want to very quickly introduce the reasons why you might want to do that and some of the recent architectural changes that have been made to DataStage that enable you to do that. So if you're familiar with the architecture of what's being increasingly referred to as DataStage Classic, so I'm talking about DataStage up to version 11.7, you'll be familiar with the idea of a Windows-based engine tier, the client that you'd use to build and design jobs, the services tier, which under the covers was a kind of WebSphere application server, and the repository tier that held all of your job designs and metadata. And of course, they all served to design and build jobs which were deployed to your engine tier, which sat co-resident with your data. And you would typically host all of those tiers on your own data center or your own cloud environment. Recently, IBM have introduced DataStage as a service. So now you can actually host all of those tiers on IBM Cloud. IBM will manage the life cycle, the upgrading, the availability of all of those tiers for you, and you can forget about all the hassles of having to own and operate sometimes complex infrastructure yourself. The challenge with that is that your data may not be on IBM Cloud. So of course, your data is very possibly on another cloud service like AWS or Microsoft Azure or GCP that we'll look at today, or even on your own self-hosted data center based on x86 technology. So given this architecture, we can actually, instead of having an engine on IBM Cloud, deploy that engine remotely to where your data resides. And this is the concept of DataStage Anywhere. Have IBM look after the life cycle of your job designs and all of the hassle that potentially comes with owning and running your own infrastructure to do that, but deploy the processing to where the data resides. Today, as I've mentioned, we're going to look at Google Compute Platform. So what that involves is we've got an IBM Cloud environment and a Google Compute Platform environment, and I'm going to connect the two using nothing more than a simple laptop. On IBM Cloud, I'll have an organization. Within that, I'll have a DataStage service instance, and within that, I will have a Cloud Pak project. Also on IBM Cloud, there is a Cloud Container Registry, which contains an image, a Docker image of the parallel runtime engine that's being used by DataStage to process data. On my laptop, I'll be using 3 commands: gcloud, which is the Google Compute Platform CLI, kubectl, which is the Kubernetes command line interface, and I'll also need to install another command called jq, which is used by a script that I will employ. I won't use that directly. On the Google side of the equation, I will have a Google organization, within there a project, and then within there's going to be a cluster, which is connected to some storage, and I'm going to be using NFS storage today. As I'm configuring some of these elements on each of my platforms manually using the command line on my laptop, I'm going to be collecting various bits of information, and I'm going to store those in a file which I'm going to call launch.cfg. What that file is going to be used for is to help us connect these two environments. And the utility to do that is provided by IBM in this GitHub repository. That's publicly available, so you just need to create a GitHub account and go there, and then you can clone that down to your local environment, your laptop, and in there you'll find a script called launch.sh, and we will invoke that script using our launch.cfg file as its parameter. That will then create all of the necessary cluster resources on GCP, and will create a remote runtime environment definition in our CP4D environment. So CP4D will know about GCP. What that enables us to do is to then deploy DataStage workloads onto Google from IBM Cloud Pak. And additionally, when there are new engine containers available, maybe fixes or updates to the parallel runtime, your Cloud Pak environment will be able to detect that and give you the option of deploying those updated container images to Google without you having to mess around with Kubernetes or the command line or do anything like that. It'll be seamless. All of those bits of information that we need to collect on each side of the equation are listed here. So we'll need to know about our GCP environment, org, project and namespace. For creating the Kubernetes engine, we'll obviously have to give our cluster a name and also some parameters, which are basically kind of sizing values for our Kubernetes engine, and also some parameters that define our network file system. On the IBM side of things, we need a cloud API key. So this is simply a way for our local laptop to be able to talk to IBM Cloud and marshal resources on the IBM Cloud environment. And you'll also need an IBM Container Registry API key so that we can talk to that container registry and get hold of that PX runtime image. You'll see there's an asterisk I've put next to that. It's a little bit uncertain at the moment what the mechanism is for you to get that. Right now you have to request that key, that API key from IBM support. I believe that will change in the future. I'm not sure when, but as of the time of recording, November 2024, you still need to get that key from IBM support. Then in our Cloud Pak environment, we need a project ID, and we need a name that we will use to refer to the particular remote runtime we're going to establish on Google. So that's it. Let's get into it. Okay, so here is my IBM Cloud environment. And I can see that I've got a organization here, and I'll be coming back here in a second to create an API key. Here within my IBM Cloud environment, I've got a Cloud Pak for Data project, which I've called DataStage Google. And I'll be coming over to the Manage tab, and I'll be getting some values from here shortly. I also have a Google Cloud Platform project called DataStage Anywhere. There's some values I'll be getting from here. And finally, I've got opened the DataStage, the IBM DataStage GitHub repository that I'll be cloning onto my local machine in order to use, if I just jump into the remote engine folder and then Kubernetes, this launch.sh script here. Interestingly, on this README file, we've got the command prerequisites, and you can see that this launch.sh script requires that JQ command, which is just a JSON query. It's a command line JSON parser. You don't need to worry about it. You won't be using it directly. You just need to make sure it's installed. And you can see down here a particular note that said currently there is no way to generate this container registry API key. Request it from this URL via IBM support. Further down, most interestingly, we have a template for that launch.config file that we're going to use as a parameter to the launch.sh script. And so what I can do is I can actually take that and start populating that with all of the various values that I need. So let me just jump over to a terminal session. Okay. So I can see that I'm in an empty folder. I've just got a notes subdirectory, and that's got a couple of personal notes for me in about this process, but nothing else. So I'm just going to copy out of that notes directory a template for the launch.config. And I'm going to open that up. And of course that's opened up on my other monitor. So let's bring that over. And I hope that the text is all the right size for you looking at this on a video. This file here, this template file, I will provide a link for you to download this wherever you're looking at this video. It's a combination of everything that you saw in the README file, or you will see on that README file on the IBM repository, plus a few of my own variables or values, key value pairs that I need just to keep track of what I'm putting into the commands that I'm going to be typing on the left-hand side here. So sometimes I'll be submitting multiple CLI commands on the left-hand side, and I'll need to make sure that values are consistent between commands. And also I want a record somewhere of all of those values that I've used to create the resources. And if you remember back to the diagram I showed you earlier, some of those resources I'll be creating manually at the CLI, and then when I run launch.sh, the remaining resources will be automatically generated for me. And this text file here is going to be the record of that. So let's start by going through our shopping list. On the IBM side of things, the first thing I need up here is a project ID. So if I just jump back to my Cloud Pak project, and I've gone to the Manage page, on the General tab, I can see my project ID here. So I'm going to copy that over and paste it there. Down here, Google, I need my GCP organization ID, project ID. Okay, so if we go over to Google, right here on the front page of my project, I can see my project ID. Be careful with Google, there's a project name, a project number, and a project ID. What I want here is the project ID. So I'm going to copy that and paste that into the project ID here. Where do I get the organization ID from? So in Google, I click this little menu up here and I select project settings. Here you can see my project name, ID, and number. And if I click on over here on the organizations tab and then select my organization, I get my unique organization ID, and I'm going to copy that. My cluster name can be anything, so I'm just going to call it DataStage Anywhere, if I can type the word anywhere correctly. And while I'm up here, I need to give my NFS file share a name as well, so I'm going to call that NFS Anywhere. Okay, so those are all of the things I need. Let's see what else the launch.sh script needs. So it needs a name of a Google project namespace. So let's just call that DS Anywhere NS for namespace, whatever. Here are the credentials for my container registry. These are the ones that I have received from IBM support. I will add those to this file off camera. You obviously don't need to see those, and they're private to me. So I'll add those before I run the launch.sh script. Here's my IBM Cloud API key. I can go and get those. So if I go to my IBM Cloud tab, what I'm going to do is go to Manage, Access IAM, and then on this page, API keys. So it's got a list of my existing keys. So I'm going to create a new key, and I'm going to call it DS Anywhere Google. I don't need to set any other settings, and like many API keys in different platforms, this is your one opportunity to get hold of the actual key value. So I'm going to copy that and I'm going to paste it into my config file. The other thing I want is the ID of my Cloud Pak project. So if I go back here, I'm done with this. I go back to Cloud Pak, and on the Manage tab for my project, I can see there's a project ID here. So I'm going to copy that and paste that into my config file. The name of the remote runtime, alphanumeric only, no punctuation or white space. So no hyphens or underscores. So I'm just going to call that DS Anywhere GCP. I've got some values here which come from the launch config template. Size small, storage class NFS client, so we're going to use NFS for storage, that's fine. Storage size. Obviously, if you're doing anything other than a POC, you're actually doing this for production where you want to kind of maybe do some performance profiling. You want a larger environment. This is where you'd select different values. And then down here, I need to specify values for my NFS server and path. So my path is going to be just my NFS name with a slash in front of it. My server is a DNS or IP entry to my DNS server, but I haven't got that yet because I don't have a server created. So let's start with creating some of the resources at the command line. I've got everything I think I need for that I can get for now in my config file. So over here, let's just verify that I've got the right commands installed. So I need gcloud, which is a good idea if you spell it correctly, like that. I have got gcloud, that's good. I need kubectl, which I have, and I need jq, which I have. If you're on a Mac, as I am, you might find it useful if you're a homebrew package manager user. You can actually use homebrew to install and maintain kubectl and also jq. The gcloud CLI command you'll need to download from the Google site. That's not managed in or not available in homebrew. The first time you run the gcloud, you'll be prompted to, you'll have the option to create a project if you want to. So if you don't have a project, by all means use that option to create your Google project. So I've got my 3 commands, that's all good. The first thing I want to do at the command line is to connect my gcloud CLI to my Google account. So I'm going to run gcloud auth login. Again, these commands I'll list for you in an attachment that I'll make available. That command has opened up an authentication page on my other monitor, so I'm just logging into that, allowing the CLI to get access to my account. We're all good. The next thing I want to do is I'm just going to, as a habit, I prefer to turn off usage reporting, which is done using that. And I'm going to just make sure that I've got the necessary plugins in my CLI by running gcloud components install the auth plugin. We're all up to date. That's good. And if you don't have a project and you need to create one at the command line, you can use this command. Forget the parameters, the variables I'm using here. That's just something I'm using in a script. But that's the command you can use to create a project at the command line if you want. I'm going to Control C that because I don't need to do that. As you've seen, I've got a project ready to go. And one thing I'm going to do is set my project, and I need to specify the project ID. So if I go back up here and get my gcloud project ID, that's now set my CLI to talk to, by default, to my DataStage Anywhere project that I've created and I'm going to be using for DataStage Anywhere. Now what we're going to do is we're going to create an NFS file server, and to do that we first need to enable the file API on this project. That's happened for me very quickly because I actually enabled it previously in the user interface. For you, that may take up to 1 minute. That's certainly been my experience in the past when doing it at the command line for the first time. Okay, so the next thing to do is to create our NFS server. We're going to use the command gcloud file store instances create NFS server. That needs to take as a parameter the name of our project and also the name of our file share, which is going to be NFS Anywhere. We'll also need to specify the capacity and a network name, which we can just use default. And I've just remembered that NFS Anywhere can't use hyphens, but it can use underscores. That's one of the kind of weird constraints of NFS on Google. So I'm just going to go back and update that in my config file. Glad I caught that. That should take a second to acknowledge. Okay, so Google is now creating our NFS file store. So if I say file store and look at my DataStage Anywhere project, I can see that I indeed have an NFS server in the process of being created. Importantly, an IP address has already been assigned to this server. So what I can do is I can copy that off and stick that in my config file. So other than my private Cloud Registry API key that I get from IBM support, I believe I have all the values in my config file that I need for the rest of this process. So we'll just wait for that NFS server to be created before we take the next step. Okay, so that command appears to have completed. Let's go off to Google and just refresh that page. And we can see our NFS server has completed successfully. Okay, so now we're all ready to go ahead and think about creating our cluster. So there's another service we need to enable, which is the container API. That happens pretty quickly. And now we're going to go ahead and create our cluster. You'll create your cluster within a zone or a region. If you're not familiar with zones and regions, you can get a list of those at the command line by listing your regions, or if you want to make that zones instead. And then within your selected region or zone, you can get the list of applicable machine types. So I'm going to use, for example, US Central 1A. I'm just abbreviating the list here to keep things tidy, just getting the first 10 rows. These are the machine types applicable within that particular zone. So I've got all of my values that I've chosen. I'm going to create this cluster. We've got our cluster name there, DataStage Anywhere, that we recorded earlier that we want to use. My zone. These are all pretty kind of standard. This is the sizing of my cluster, so the number of nodes. You'll obviously change this for production purposes. Machine type, disk type, and that should be good enough to go off and create our cluster. You'll get a few warning messages about previous about deprecated ports and whatnot, but you don't need to worry about those. So it says cluster is being configured. Let's jump on over to Google Cloud. I'll click on my project front page and go into Kubernetes engine, which you can also get to from the menu here. And you can see that I've got a DataStage Anywhere cluster in the process of being created. And if we just click into there, we can see that there are 3 principal steps in creating the cluster, and we're currently at the first step, configuring, and we're 27% of the way through. So we'll just sit tight and wait for that cluster to complete creation, which typically takes, in my experience, somewhere in the order of about 10 minutes. Okay, so that command's completed, and if we just refresh our view of the cluster to make sure everything's up to date, I'll click on nodes, and we can see that we've got a node pool and 2 nodes defined. So those are the basic Kubernetes resources I need. The next step is to connect our Kubernetes cluster to our IBM Cloud Pak environment. So now we've got a Kubernetes cluster up and running, we can now use kubectl to talk to it. So if I just do kubectl, have a look at my local config, I've got some values that have been inserted in there. What I'm going to do is I'm going to just ensure that my local credentials are up to date. So I'm going to say gcloud container clusters get credentials, and I need to not use my parameter name, but we from my script that I've got on my other window, but I actually need to use my proper cluster name, which is DataStage Anywhere. And that has set my kubectl command to now talk to my cluster. And if you did it earlier, but if you want to just double check that, you can say kubectl config view, and that will tell you about your cluster, your contexts, and your users. Okay, what we're going to do in our cluster is to create a namespace, and remember we're going to call our namespace DSAnywhere.ns. So that will just act as a way of isolating the resources that we're creating for DataStage Anywhere from anything else that might choose to use that cluster. If you or another user creates other resources in that cluster, at least we'll know which ones are related to DataStage Anywhere. So that namespace has been created. And what we're also going to do is to annotate the namespace. Annotate the namespace. I hope you can type better than I can. With a reference to our project, so that any resources created in our project go into that namespace by default. And our project ID was DataStage Anywhere 004 without the space. And DSAnywhere. Oh, I got it totally wrong. My apologies. DSAnywhere NS. Cool. Okay, so that annotation's happened. That is, you'll be glad to know, the end of my terrible typing, because now we're at a point where we can run our launch.sh script from the GitHub repo that IBM supplied. However, I have yet to bring that down locally onto my local machine. So I'm going to go to the front page, select the SSH clone reference, and I'm going to say git. I'm already authenticated to GitHub in the background. I have a key on my Mac. I can just say git clone. I've got an authentication window popping up. There we are, that's done. Okay, and I have a local repo. And so now I can run my DataStage launch.sh. I'm going to use my launch. I've currently got this file called launch empty. I don't like that, so I'm going to just rename that. Actually, just save that. I'm going to move launch empty to launch. Let's call it gcp.config. Launch gcp.config, and you may have noticed that in the config file there was a line that said accept license. Despite that being in the file, I've also found from personal experience that my launch.sh script only reported success when I specified license accept true at the command line as a parameter as well. So I'm going to do that. Those are the kubectl and jq commands it needs. Retrieving digests for container images. Missing, of course, I have forgotten to add my IBM container repository API values. So I'll just go and do that quickly. There we go. And that was a carefully calculated demonstration of what happens if you don't put the values in. Now this script will take just a minute or so to complete, but then once the script has completed, there will then be a 10-minute or so process while all of the various containers get pulled and provisioned and all the rest of it. So we'll just wait for the script to complete. Okay, that script's completed. You'll get some errors about a resource type px runtime not existing yet. Of course it doesn't, we're in the process of creating it. And it gives you a command here to check the status of the creation of resources, which we'll just run. And we can see that things are in progress. So I'll just actually stick that into a bit of a loop. So I can keep, oh come on. Definitely haven't had enough coffee today. Okay, so that's just going to run every minute so I can keep track of the background progress. And if I just go over to Google and have a look at my two nodes here, I'm just going to open them up in different tabs. So we can see that this first node, we have a px runtime pod and a px compute 1 pod. And those containers are in the process of being created. And on my other node, I have a compute 0 pod in the process of being created. So that will take about 10 minutes or so. We'll come back when that's done. Okay, so our command is telling us that pod creation is complete. So if we go over to here and just refresh our view, we can see that compute 0 is running and px runtime and compute 1 are running. But most importantly, if we go over to our Cloud Pak environment, we can see that now in our list of available environments, I have a DS Anywhere GCP template, which means I can go to my DataStage project settings and convert this IBM Cloud project to a remote project, which means that once I convert this to a remote project, this project can only then use remote runtimes. And we can see that available runtimes here are DS Anywhere GCP. So I'll save that, confirm that I want to do that, and we're done. This is now a remote capable DataStage environment running workloads on Google Compute Platform. And just to demonstrate that, I'll create a quick job. Okay, my job has completed, and we can see that the host name is our DataStage Anywhere GCP runtime. Okay, thanks everyone. I hope you found that useful. If you've got any questions or comments, please feel free to add them down below. Otherwise, I'll see you in the next video where I will show you how to do exactly the same thing on Microsoft Azure. Thanks.